Welcome to Command Shift Left, the podcast that helps you navigate the treacherous waters of the software development, ops, and security world while also diving into the hot current trends in the industry. Join myself, developer Philip, our co-host or Vice.
Hey audience!
As we battle through hilarious real-world stories, pro tips and hacks for navigating your way around developer security, learning about our Shift Left life, and life stories that have saved our ass. We have two incredible guests with us today, Anders and Erica, where it's an absolute pleasure to have you guys with us. And why don't you give a very short introduction about yourself? And let's start with Erica.
Hey, I'm Erica Brescia. I'm a managing director at Redpoint Ventures. We're an early stage venture firm that invests in technology companies and loves partnering with founders from the earliest stages of their journeys. I'm new to the dark side, though, a year and a half into venture. Before this, I've spent my whole career as a founder and operator. Most recently, I was COO of GitHub, came in following the Microsoft acquisition to mature and scale the business. And we got to launch a bunch of amazing products when I was there. And then before that, I founded two companies in the DevOps space. And my last company, Bitnami, was acquired by VMware right before I went to GitHub. So happy to be here.
Amazing. Awesome. It's amazing to have you. And Anders?
Yeah, I'm Anders. I work as a developer advocate at Styra. So I've been involved in the OPA or Open Policy Agent project for the past 4 years or so, which I know Or has been as well. So I've had the pleasure to meet before. So yeah, I'm basically involved in anything around the OPA community, OPA development, OPA tooling, and whatnot.
Amazing. Excited to have you both. And I think without further ado, we'll jump right into our facts. And the first fact for this episode is mine. And my fact is that when my wife wanted to up our AC, she opened a pull request. So I've recently, I've been using Sensible, which is a kind of a small IoT device to manage your air conditioning, but I wasn't happy with how it's balancing humidity and temperature. So I wrote a small script and an app to kind of manage it, but my wife wasn't happy with the balance. So she opened a pull request to update my code to get it to be more aligned with what she wants. In general, what I'm trying to do with it today is and what I think like most devices should be aspiring to do, to have a simplified interface where you just express what you want. So each household member can say, I'm hot, I'm cold, I wanted to keep it as is, and the system itself could balance it out. Just kind of sharing, I've built this with a stack based on Sensible, TypeScript, Vercel to kind of host this, Opstash for a database as a key value store, and I did authentication with super tokens and authorization or permissions, obviously with permit, otherwise it would be very silly. And that's kind of the basic thing here. But something that I want to take this, I always like to take facts into kind of thinking on one meta level more. What if we took every spousal argument that we have or any conversation that we're kind of have disagreement and translated it into GitHub and pull requests? Would that create better conversations or worse conversations? What do you think?
Better for a little while and then no conversations. That is like, I mean, it's cool for a minute and then it's like deeply concerning.
Like I can think of like, oh, my wife is not happy with how like we're doing chores, like how I fold the laundry or how I set the dishes after I wash them. So we can like have a code review for the algorithm or the script for how we do that and standards. And then like, and when someone says, oh, but you said you'll set the table that way and you didn't. They're like, well, I never said that. Really? This commit says.
Is this in general something that you're planning to do with all your household appliances?
Well, not in the moment. The other ones are kind of more simply automated. Like I have a Roomba and I have like smart light bulbs, but that's basically it at the moment. Maybe I can do something with the light bulbs. That could
Wait, so essentially your AC came with no control over it, and you created a whole dashboard where you can now control everything for a nice UI. Is that right?
So Sensible is a great product. It's actually made by a friend, so I'm happy to promote.
Okay.
And they're a great company. They're actually doing well. The cool thing about it is it just latches on through the infrared controller. So instead of the remote that you get for AC, the Sensible device just sucks your AC through that. And it does come with a very sophisticated app where you can control both the temperature and all the different modes for the air conditioning. You can do everything you want that you can do with the remote, you can now do from your phone. But it doesn't have, and it has some smart automation, but it doesn't have logic to balance humidity and temperature. You can either tell it to optimize for humidity or for temperature. But the two, like what you end up feeling actually is kind of dependent on both. So I wasn't happy with that. So I had to write a little bit of code to augment it. And the thing that I actually want, I don't want sophisticated UIs. I just want a button that says, make me feel well. Like, I don't want to also like think about my wife. She's cold, so she'll up the temperature. And I'm like, why is it hot now? I'll lower it down and we'll fight through the app, which is silly. Instead, we should agree on a policy, and maybe even enforce it with something like OPA. We should agree on a policy of how the temperature is set. That's my...
Oh my gosh. I want to be a fly on the wall in your marriage, or this is wild.
You're welcome. Next time you're in town, you're welcome to join my wife and I for dinner.
I still
Do I
sometimes
have to like type everything into the command line or something? Sorry, Philip.
No, that's the plan that we have with our kid. He's only 9 months old, but we'll get him there.
In general, I always kind of get curious because you come up with these crazy ideas that you have time to do it. But I'm always wondering, where do you find the time to do this when you're running a whole startup?
And has a baby. Let's not like that. We have 2 babies, startup baby and human baby.
So with the startup baby, it keeps you awake for other reasons. The human baby keeps you awake for just being awake and not falling asleep. So you have a lot of time where you're not sleeping to just dream up crazy ideas. And that's how you end up doing a startup anyway. You dream up a crazy idea. I think this is a perfect time to move to our next fact. And that fact belongs to Anders. Anders, take it away.
Sure. Yeah, so it's kind of related to the topic of like household appliances. The fact I wanted to talk about was like the weirdest bug I ever encountered, which was, I don't know, 10 years ago or so. I lived alone in a flat, and I had a laptop at the time running Debian, and I was like, when I was going to clean the apartment, I would always put on a playlist just to have some music on while I did so. Mm-hmm. And I noticed like whenever I would clean the apartment, the music would just stop, and for like no good reason. And it didn't even occur to me like why, but after a while, when I noticed this is a pattern, like the music always stops when I start cleaning. How can that be? So eventually it turned out like what happened is when I turned on the vacuum cleaner, is that is what like had the music stop.
Wow.
Which is like, that was not even connected to my computer, or this is way before like, what are they called? Like these robot. It's not like a robot. Well, it's like the old fashioned, like really old.
So I'm guessing this is like an electricity thing, like a power thing.
Yeah, that's what it turned out to be, or that's what I think it was. Somehow, like when you start like an old vacuum cleaner, there's the power surge, which somehow had, and eventually like I started debugging this, and I could see like that there's a kernel module crashing when I turn on for my sound card in that laptop, which was not a very good laptop and so on. But I was dual booting on Windows, and when I did the same on Windows, it would work. So it was not just like a shitty hardware, but a combination of like shitty hardware, a bug in the Linux kernel, and a power surge, that is the most weird bug I ever encountered.
Did your laptop have to be plugged into the wall for this to happen? Or was it even... Yes.
Yeah, no, yeah, it did. But that was... I kind of regret now not filing a ticket for that, because it would have been like a fun historical record.
Sure.
But it was like, it just seemed so bizarre that that would happen. And of course, like, if anyone would ask, like, how would we reproduce this? It's like, you basically need to fly over here, and do this in my apartment with this vacuum cleaner and so on. So that was, I never got to that, but I kind of regret that now.
Do you still have the device?
No,
the device is in question?
I don't. Sadly, not.
That's a shame.
Did you end up changing the vacuum cleaner?
Nah, I just had to clean the apartment without the music, I'm afraid.
Well, I think this is the rise of the robots. They basically they won this battle, so
yeah,
we need to get them back.
I'm feeling like my life is severely under automated now. I'm going to leave this podcast and think about all the things that I need to go
That you could automate,
build and fix to run my house. I mean, like work is automated, but not this kind of stuff. I'm good food for thought.
Nah, don't feel bad about that. Like I'm not very much like into home automation either. I'm very primitive when it comes to anything like that.
I was just getting into home automation, and I had a similar debug issue because I ended up purchasing 2 Amazon Alexas to somewhat allow me to stay informed or write some routines on it. And then every time I connected the second Alexa to my network, I suddenly ended up killing the internet in all my devices in my whole house. And I had absolutely no idea why that is happening. Now, first of all, I thought it's a faulty Alexa, but then it proved not to be. And there was like no way to debug it, because every time I had to unplug one device and check if it works again, and then still that internet would just completely crash. Long story short, it actually turned out to be a network issue with my router. And it wasn't even the physical device, it was something on their network. But I found it very astonishing how a device that was plugged into Wi-Fi caused this whole crash in the whole house. And there was no getting back to it. You had to call the internet service provider and tell them, and they would have to restart your connection again for it to just come back and then break again suddenly minutes later. So home automation does seem to be a little quirky still. I don't know, there's still some devices that do well, but still some that are just, have the bugs in them that you just find.
I think as developers working in the cloud, we get used to virtualization of everything very, very quickly. And when in a virtualized world or container world, everything is the same. So if you want to test it or replicate it, it's very easy to do. And we kind of take it for granted at this point. But there are still a lot of situations like with IoT that you're still dependent on very specific elements of physical environments that you need to tackle. And actually, I want to share a quick sub fact from my time in the military. So I worked in intelligence, and we had to build an intelligence project that required a very specific device. I won't be able to say which device. And I had to go through really insane pipelines just to get a hold of that thing, because you couldn't replicate its behavior. It's like everything proprietary. A lot of specific firmware that exists only in that thing. So I really struggled, and we ended up getting it in really a lot of different chains that eventually we got that device. And then I had a meeting with my counterpart at the NSA. And turns out that they were working on a very similar project. We didn't know it at the time, but they were. And I asked them, and this is actually an answer that they give for a lot of things that we ended up talking about. Asked them, so how did you end up having that device and figuring it all out? And he said, we just bought the entire company. So the difference between scales of power and different, I'd say, developer culture.
Oh my gosh.
You got me curious now. Like, what was that device? Was it a vacuum cleaner?
Well, the two options, you'll either have to kill me or I'll have to kill you. So I think we'll just skip that part.
Yeah, let him do that. All right. Well, I have a fact that kind of speaks to your point about like cloud and containers and how easy it is to do things now. So I'm going to date myself. Please don't go do the math on how old this makes me. But when we started my first company, we were building initially like native installers, and then we built VMs, and then we built like cloud images and then containers for popular open source projects. And we'd take whatever the project was. It could be like Sugar CRM or MongoDB or whatever it was. We would build a complete like self-contained stack of everything that you needed to run whatever the application was. And we needed to build in such a way that these, first starting with installers, would run on any Linux distro. Like you could have one installation package that would run on any distro instead of, having to build uniquely for each target environment. And back then, containers weren't a thing and Packer wasn't a thing. So we used CH roots and we built our own Packer before Packer existed so that we could build our own completely self-contained installation packages. And like, even thinking about that, I'm like, we used to support like Solaris and OpenBSD and like all of these Unix distros. I know I told you I'm super old. I was young when I started this company. Just to be clear, I was very young, but still, yeah. So how good you youngins have it from when we used to have to do this. Do you even remember installers when you like download an installer to put something on your machine as opposed to just like downloading something from an app store or whatever?
Do you want me to pretend I remember, or should I just be honest?
When you actually don't remember?
No.
Okay.
I'm glad we've moved on from that time. It is a better time. I mean, it's mostly a better time. I don't know. Kubernetes is still pretty freaking complicated. So like you can do a lot more very cool things and you can automate a lot more, but it's also like, I mean, it's not that easy.
Yeah, if it makes you feel any younger, Erica, I used to work on a team, an adjacent team to mine was the mainframe team, where they would we had some dependencies to their code. And at one point in time, I found a bug in their mainframe code, which I needed fixing to proceed. And so I went over to that team because they were not working with pull requests or anything. So if you wanted something changed, you'd physically walk over to the team and you'd ask someone. And he said like, okay, yeah, sure, I'll take a look. And he started coding, and he said like, okay, I fix it. And I was like, okay, that's great. And I hadn't even made it back to my desk before I heard like, oh, there's an alert, like something is seriously wrong now in production. And it turned out like he was coding this fix straight to production with no tests.
Oh my god!
And
he had made an off by one error. So this was a pagination feature where it would, like, if you click to the next page, it would just paginate forever because the loop would never stop.
Oh, jeez.
And this was done on the mainframe, like main thread. So it would just lock the whole machine. So I'm that many years old.
I do feel better now. Thank you, Anders.
I'm kind of wondering how these conversations are going to sound in the future. Like, back in my day, we just had Kubernetes, and we didn't even apologize to you when it would take off your nodes. No, and it wasn't even sentient. You couldn't talk to it.
I was going to say, AI is going to be writing all of our code in the future and dealing with all this. And
I think it already does, huh? It already does.
It's getting there.
To some extent, I'll tell you, I have a 10-year-old. I went into his room this morning. He wanted to write a song for his camp. He's in like summer camp right now for the bus.
Yeah.
And we had been working on this as a family last night a little bit before he went to bed. And then he got up early to finish it. And I looked at the lyrics and I was like, that's really, I'm not sure it matches the music, but like, that's really good. I'm like, did you write that? And he's like, no, I didn't have time. I just used ChatGPT. I was like, oh my God. It is a wild world.
Wow.
I don't know. Did you see that GitHub report on Copilot? I mean, obviously it's continued to grow. We built Copilot when I was there, but like 40% of all the code in repos where Copilot's enabled is written by Copilot. It's crazy.
Oh, wow. 40%. That's a lot. That's a big
But
chunk.
how much of the good code is written by Copilot? That's a real question.
You'd have to like be in the editor to see how much people are like changing the code before they commit it.
Right.
But that'll come soon enough. A lot of people, including one of our companies, is doing some really cool stuff with code editors and like how you interact with a coding Copilot. But
Yeah.
I don't know. I think it'll get good really fast. Or I mean, I think it's already decent for like very basic thing. I mean, people are going to Stack Overflow and copying stuff and pasting it forever anyway. So like this is just like the automated copy and paste from Stack Overflow. But like,
Yeah.
I wouldn't bet against the speed of improvement.
Yeah, at least ChatGPT doesn't shout at you, whereas in Stack Overflow, when you ask an indecent question, you really roasted.
I heard a story today from a friend who's in the organizing committee for a conference, and he said like so many of the submitted talks now, they're just like, he could tell.
Oh, really?
It's just like ChatGPT. So people are using ChatGPT to create the
Submissions.
what's it called, like the abstract, which is
Yeah.
like, how are you supposed to talk about this? Like, if
You can potentially get a lot of talks this way. Just run a script that just any request for a submission you find, you just generate something from the title of that website, and just you might end up getting some talks. I'm sure people have already done that.
Oh my gosh.
If you done it,
yeah, but you're actually gonna have to talk too, right?
Yeah, you're gonna have to deliver the talk after. I guess they'll use ChatGPT to write it. Somebody just asked me to chair a track at a conference, and I was already probably not going to do it. Now I really don't want to do it.
I think now would be the perfect time to move to our third fact, and that one belongs to you, Philip.
Okay, I'm going to take it away. So my fact for this episode was that the first ever written computer game was developed in 1948, and that was done by Alan Turing and David Champernowne. I believe that's how you pronounce it. Now, what they developed is a game called ChuroChamp, which was a chess simulation. Now, what I find really interesting about this, and I'm always curious what was going through their heads, is that they developed this game, I suppose, in some way, perhaps to play it. But funnily enough, because it was in 1948, they were the only ones that could actually do it. Because at that point, nobody actually had a physical computer in their house. I believe that the time when people actually started buying computers and using them in their own home was about 30 years later. So around 1977 or something like that. Now, the game ChuroChamp that they did develop, it actually had a lot of impact into the way we do things. So, for example, ChuroChamp attempting to play chess actually gave a demonstration to people at that time that there is a potential of computers perhaps being opponents to you. And it actually encouraged a development of computer games and gaming platforms, and therefore kind of leading to this thriving game industry that we have now. On the other side of this is that, of course, when that computer game ChuroChamp was developed back in the day, it had a bunch of limitations. It had limitations like, for example, like I said, barely anyone owned a computer. There were a lot of hardware limitations. There was a lot of things to do with computational power that just couldn't run the game. Obviously, they struggle with storage capacity. And actually, the biggest limitation there at that point was that people didn't actually know how to play chess that well as well. So the game wasn't, the techniques of playing chess weren't as developed. So people didn't know how the game worked. But the whole concept here is that this whole evolvement of the game is a standpoint of and kind of notified people at that age that there is a lot to look forward to and a lot that can be advanced in this kind of principle. And where we could get to in the future, and it just proved a lot of concept for just general like what we can believe computers to be. So what we imagine computers to be now in 40 years, I guess this is the kind of hint that they had because they understood that there is a possibility to get there at some point.
Amazing. Like I didn't even know that you can. Maybe that code is available elsewhere, but I didn't know that you can actually find code that Alan Turing wrote and that you can potentially use. Like Alan Turing was like a mythical figure, like that brought up computers out of the abyss. And for those, if somehow someone doesn't know, like a Turing machine, like it's the basic architecture for all of computing that we use till this day. Everything, all the mathematics, all the basic concepts there, he set up. So that mythical figure actually writing software that is relevant to day-to-day stuff is kind of almost in misalignment in my mind. It's like you tell me God is having coffee next door or something like that.
Yeah, well, I mean, to my surprise, it was just the whole concept because, I always heard and read that, Alan Turing was very deep down into like the deep concepts of computers, not writing a game for this instance. So it's kind of a big difference here that I was never aware of.
Mm-hmm.
Yeah, I guess a question then would be if they were doing pull requests as well or having changes.
I'd imagine they coded it at the best case scenario on punch cards, and maybe not even that.
Right.
Like the actual physical elements that they set up within a machine that they had. That's actually interesting to find out how did they actually program it and how they actually ended up compiling and executing the code there.
Wasn't it the case that if you made a mistake at that point in time in a punch card, you had to just redo the whole punch card?
Yeah.
Was that the case?
Yeah.
That's a difficult bug to fix.
Yeah, but you had a series of cards running one of the arrows.
Right.
So it's not like, and usually you had a limited set of instructions per card. So that wasn't that big of an issue. But just having to go and physically change every opcode on a card, like we're complaining today about CI/CD and having to go through tests or regression tests or having some friction to deploy to production. Just imagine just having to, for every little change you want to do, have to walk around the room and physically mess with objects. So it's almost...
I think it's even worse than that. The other day, I found myself complaining when I asked ChatGPT to write something for me, and it got it wrong. And I was complaining at ChatGPT saying, "Why are you doing this wrong?" I think it's even worse than that.
Yeah, again, it's interesting to see the complaints that our children will have as they will be writing software.
But I think wasn't the first bug was an actual bug as well?
That's why they're called bugs. So it's I think it was a physical beetle or a moth that crawled into a transistor, and the computer back then was the size of a room. So there was actually a lot of space to crawl into, and actually bugging up the software.
I cannot believe I've never heard that before. That is a fascinating fact.
Yeah.
All right. I think it's about the right time to move to our final fact of this episode. And I believe that fact is by Erica. So Erica, why don't you take it away?
Yeah, and I have a surprise fact, and it is conveniently related to bugs. So this is a fact about the Ubuntu community. It's like my favorite debugging fact and story that I've ever heard. So I'm stealing it from them. So a bunch of the Ubuntu team, my husband worked on Ubuntu for a very long time, and from the early days, he built the Ubuntu community.
Nice.
And they were at a sprint in Dublin. And there was a bug that was happening in the kernel before the screen initiated And so they couldn't see the error logs. They couldn't figure out what it was. And so this guy, Colin, on the kernel team had the idea of flashing the light on the caps lock key in Morse code to figure out what the error log was. And he like ran to this store called Maplin and got this light detector, and he put it on the caps lock key and then wrote something to convert the light flashing in Morse code back into like human language to get the error. And then they found the bug and they fixed it, and they shipped the fix the same day.
Wow.
It is so freaking cool.
That's
First of all, I didn't know that the caps lock key flashed in Morse code. Was that just a thing?
There's a LED in some devices, in some keyboards. You have a LED telling you if the caps lock is toggled
on or not.
Yeah.
Right.
So they wrote something to take the error code and type it into like translate it to Morse code, flash the key light in Morse code. Then they had the light detector that captured the Morse code, and then they had to write something to translate it back. And they did this in the course of one day. This guy had this idea. I'm like, I love the way your brain works when you figure out that path to trying to figure out what the logs were saying. It's pretty magnificent work, I think.
Yeah,
that's great.
It's a real great hack, and it's lateral thinking. It's like thinking out of the box, literally in this case. And,
literally, yeah.
Yeah, and I think a lot of times that's some of the elements that you want in your best engineers. Like a lot of times we tackle problems that might have straightforward solutions for, but those will be either costly, be challenging with performance, or it would just require a lot of additional resources to implement. And sometimes you can just think out of the box and come up with a hack like that, and that's very inspiring. I'll try to keep it in mind and use it as a fact to encourage my engineers when they get stuck.
Yeah, it is a cool story. It shows such ingenuity, and I think like in a way it's complex, but it's also simple. Like, okay, we can't see the screen. Like, how do we get output out of this thing to figure out what's going on? Like, oh, there's a light. You know what I mean? It's
But it takes such creativity, I think, just to come up with an idea of even doing something like that. Like, I don't think I would ever think of something along these lines of just using like physical hardware to try and transfer a message back. You know, it's completely out of the box.
Yeah, I wouldn't either. But yeah, I mean, there's some pretty smart folks on the Linux kernel team who are also apparently pretty creative to figure that out. But yeah, I can't get over that story.
How long did it take for the information to kind of pass through? So how much data did they need, like the log was actually, and what was the frequency that they were able to transmit? I don't know if you know that, but it's kind of interesting.
I never asked that question. I don't know. I wasn't there. Jono was there. I could text him. He might get back to me and tell me while I'm on the call. But yeah, I don't know. I mean, hopefully not too long, because Morse code isn't, I don't know, it seems like not incredibly efficient, but yeah.
There are a lot of projects where people are trying to deduce information out of a room. This also kind of relates to intelligence work. But for example, there are solutions based on AI or other algorithms that you can look at a pane of a window, for example, and from the way that it vibrates, reconstruct the audio in the room. So it's kind of a similar thing, and there's always these conversations of how much bandwidth you can encode on the transmitting channel, and then what's the sampling rate that you need to have. And it's interesting to think what else you can deduce about the behavior of a computer from the blinking lights that it has, or from the volume of its fans as they're spinning. And that actually makes me think of an allegory that is kind of cool to think about. I have a friend who's a neuroscientist, and he said, when we do brain scans like MRIs, CTs, to figure out what's going on in the brain, it's essentially the equivalent of looking at the temperature or the speed of a fan on a computer to figure out what's the computer trying to process. That kind of tracing this all the way back. So this kind of lateral thinking, maybe this is what we need to kind of crack the secrets of the human brain.
Yeah, we'll just need to attach like a scroll lock or a caps lock key to your brain so you can emit.
Isn't that something that we always did naturally? Because when we first, for example, when I first built my first PC, there was always that kind of thinking when the fans were going too fast. I was like, is there like something wrong with the computer? So you would like imply that there is, from one thing happening that there might be something going wrong. So I assume we have that fundamental kind of thinking ability of trying to, reason with what we have around us.
So there's correlation, but is it enough to actually deduce what's going on?
This is maybe a bit tangential, but I thought it was really interesting. It was a company, I'm not invested in this company, but I saw this YC company that was working on like physically securing things like nuclear plants and stuff like that. And the technology that they had developed and like their unique insight is that they were measuring power consumption on all of these different devices to identify whether or not somebody was trying to hack into it or if they had put some kind of nefarious code on it, because you would have like this very steady state power consumption and then see like spikes in behavior, which I thought was, it's obvious when you think about it, to your point about the fan and everything too. Like it is obvious, but it's not something that certainly would have immediately come to mind in figuring out, hey, did somebody put a nasty piece of software on this thing in an airplane or on this plane or something?
It's actually, it's very smart, but it's very challenging. Like I'd be worried about the false positive rate that you have, that like sometimes you have just cron jobs running on a machine, or someone is using them remotely for legitimate reasons, or sometimes they just malfunction. There's like a bug, or there's a software update, and they'll move out of their usual energy output or consumption. But it is a cool idea.
I think this is for things that aren't connected to the internet for the most part, though. Because I take your point. For most things, it wouldn't work. But if you have something, it reminds me of like this centrifuges that we hacked into, right? Or something where you have to actually get the code in some other way. You can't just they're not doing normal software updates and stuff like that to these systems.
I think the point that you're actually using actually kind of proves that it's pointless to not connect things to the internet. It doesn't make them more secure. It makes them less secure because they're not getting updated as fast as they should be. I'm trying to really form a crusade against air-gapped networks. There were a cool idea. It's time to chuck them out the window. It just makes selling software and building things harder, and it doesn't actually protect anything. That's at least my 2 cents on the matter.
That I'm not about to get into an argument about cybersecurity with someone out of the IDF. So I will cede you that point. You're far better informed on that topic than I am.
Yeah.
I'd say the opposite. Like if someone from the IDF says we should connect everything to the internet, like maybe we shouldn't.
Good
to
point.
be fair, I've finished with my service getting close to 10 years. So yeah, but I have other nefarious goals in life now. So
one of them is now how to make his AC LED blink when his wife isn't happy.
I think this is a perfect time to wrap up our episode. And any last words? Anything you want to communicate to our audience? Maybe where to find you on Twitter, or to subscribe to something that you're working on?
Just my first name and my last name on pretty much any of these social networks, or I'm mostly on Mastodon these days.
Cool. So not on. I said Twitter. I should have said X. Or you'd find me at Orweas, ORWEAS, anywhere on the web. You'd find Philip at Developer Philip, especially on YouTube. Join his masses of followers. Eric, how about you?
Yeah, I'm Erica Brescia on X/Twitter. I love to hear from anyone building anything cool in DevOps, infrastructure, security, or AI. So yeah, reach out if you're building something awesome. I'd love to chat.
Thank you guys for joining us today. We loved having you, and we'll see the audience in the next podcast. So bye.
Bye, everyone.
Thanks.
Thank you.
I think this is the perfect time to wrap up the show. If you liked this podcast, tell your friends about it. If you didn't like it, tell your enemies about it. Hey, it's Philip. There is a few little things I quickly want to add. If you enjoy Command Shift Left, make sure you leave us a rating on the platform you are streaming from. We will be eternally grateful. If you are not doing so already, make sure to follow us on Twitter, Instagram, Facebook, or LinkedIn by typing in @JustShiftLeft, all one word, for any updates and new episode releases. Finally, this podcast is fully supported by Permit.io, of which me and Or work at, so make sure you go ahead and check out Permit if you need a simple solution to implement authorization. That's all, and we will see you in the next episode.